All right, let's dive in. Today, we're going to look at a paper that tackles a huge challenge in AI. How do we get our incredibly knowledgeable language models to actually be smart planners? We're talking about a new architecture called MAP. And folks, this could fundamentally change how we build the next generation of truly autonomous AI agents. I mean, it's a real head scratcher, isn't it? You have these massive AI models, like GPT-4, that can ace medical licensing exams, pass the bar, but then you give them a relatively simple logic puzzle, something a child could solve, and they just fall flat on their face. It's this bizarre disconnect, and it's the central paradox we're digging into today. And this paradox really gets to the core of the problem. For all their amazing abilities, even our most advanced large language models, our LLMs, have this massive blind spot. When it comes to planning, to thinking more than one or two steps ahead, they seriously struggle. And that has been a major roadblock for anyone trying to build AI that can act independently in the world. So what do these failures actually look like? Well, the paper spells it out, and it's pretty frustrating. These big do-it-all models will just make up moves that are completely impossible. They'll break the most basic rules of the task. They get stuck in these maddening loops, trying the same wrong move over and over. And they're so brittle, you introduce one tiny change to the problem, a little detour, and the whole system can just completely fall apart. So let's be super clear. The issue here isn't that the AI isn't smart enough. It's not a knowledge gap. It knows the rules, it has all the facts loaded in. The real failure is architectural. It's like having all the world's best ingredients in your kitchen, but no recipe. It just doesn't know how to organize all that knowledge into a coherent step-by-step plan. And that brings us to the really brilliant solution that this paper proposes. Instead of trying to build one single giant AI brain that has to do everything, what if you built a team? A coordinated team of specialists where each member has a specific job. And here it is. Meet the Modular Agentic Planner, or MAP for short. The core idea is so elegant. You take the messy, complex act of planning and you break it down into distinct roles. Then you assign each of those roles to its own specialized LLM-powered module. It's literally teamwork makes the dream work, but applied to AI architecture. So who's on this AI dream team? Let's meet the players. Each one of them has a very specific and absolutely crucial role to play in the whole thinking process. Here is the starting lineup. You've got the task decomposer, who's the main strategist. Then there's the actor, who proposes the plays. The monitor is the all-important referee, the rule enforcer. The predictor and evaluator work together as the team's futurists, looking ahead. And then you have the orchestrator, the project manager keeping the whole thing on track. So first up, you have the task decomposer. Its job is pure strategy. It looks at the big, intimidating final goal, like solve this entire puzzle. And its job is to break that down into smaller, much more manageable sub-goals. Things like, okay, first, let's just get this one piece into the correct position. Next, once a small goal is set, the actor jumps in. This is the creative engine of the group, the brainstormer. It looks at that current sub-goal and just generates a whole list of possible actions the agent could take right now to try and achieve it. And this is where it gets really, really smart. Before any of those proposed actions are even considered, the monitor steps in. Think of it as the strict gatekeeper. It checks every single proposed move against the rules of the task. If a move is invalid, it gets rejected on the spot. And just like that, you prevent all those hallucinated, impossible moves we talked about earlier. Then you have this dynamic duo of foresight, the predictor and the evaluator. They work as a team. The predictor takes a valid move and asks, okay, if I do this, what will the world look like in the next step? Then the evaluator looks at that predicted future and asks the really important question. Is that new situation actually any good? Does it get us closer to winning? So, we've met the team, but how do they actually work together? Well, it's not chaos. It's a highly structured, repeatable loop. It's their playbook for how to think. Here's how the process flows. First, the decomposer sets a sub-goal. Then the actor proposes a bunch of actions. Crucially, the monitor validates them, throwing out any bad ideas. Then, the predictor and evaluator perform a search on the good ideas to find the very best one. That action gets added to the plan. Finally, the orchestrator checks if the sub-goal is finished. If it is, awesome, on to the next one. If not, the loop starts over. It's this constant cycle of propose, check, and select. Okay, so this all sounds fantastic on paper, right? A well-organized team of specialists should absolutely crush a single genius trying to do everything. But does it actually work in practice? Let's look at the results. So the researchers put MAP to the test against the Tower of Hanoi. This is a classic puzzle for a reason. It's notoriously difficult. It's the perfect challenge because it forces you to think multiple steps ahead. You can't just stumble your way to the solution. And wow, the results are just staggering. MAP solved 74% of the problems. That completely blows past what a standard GPT-4 could do. And look at this, it absolutely crushed another advanced method called Tree of Thought, which barely squeaked by at 6%. That's not just an improvement, that's a monumental leap. But for me, this is the most telling result of all. Look at the number of invalid moves proposed. Other methods are trying to make illegal moves almost a third of the time, but MAP, a perfect 0. That's the monitor module earning its keep. It proves the system isn't just effective, it's also reliable, and that is so important. And this wasn't just a one-hit wonder. They tested it on PlanBench, which is a much harder, more generalized set of problems, and MAP continued to dominate. What's wild is that on these harder problems, they had to disable the full look-ahead search, but the modular structure by itself was still enough to deliver a huge leap in performance. So, what's the real secret sauce here? The researchers did what's called an ablation study, where they remove one module at a time to see what happens. And this right here, this is the aha moment. Look what happens when you take out the monitor, the rule checker. Performance absolutely plummets, from a 74% success rate all the way down to just 27%. The takeaway could not be clearer. Having that dedicated rule checker isn't just a nice feature, it's non-negotiable. The paper itself says the monitor was the single most important component. It proves that a massive part of intelligent planning is simply preventing yourself from making stupid mistakes. So let's just zoom out for a second and think about the big picture here. What does this modular approach really tell us about the future of AI and how we should be building these agents? For anyone building this stuff, there are a few huge lessons. 1, specialization works. A team of experts is way more effective than a single generalist. 2, reliability is just as important as raw power. That monitor module is all about building trust by preventing errors. And 3, and I just find this fascinating, this architecture mirrors how our own brains work, with specialized regions in our prefrontal cortex collaborating on planning. And that leaves us with this final, really provocative question for the future of AI. Are we trying to build one single, all-knowing, monolithic brain? Or is the real path to truly intelligent systems through creating a smart, collaborative society of specialized agents that can work together to solve problems far bigger than any one of them could handle alone? It's definitely something to think about. This is for entertainment purposes only.